Today's entry ticket is going to cover density. Defining density. Density is a quantity divided by volume. There's an example video, really very similar to what the common mistakes that we're going to cover in this entry ticket, where density is some quantity, typically a mass in this class, divided by some volume. It's how many kilograms per cubic meter in this case. And then other formulas we need to be aware of. If you click on these links, it takes you to links for all formulas we're using in this class. Volume of a pyramid is 1/3 times the base area times the height, something we've covered already. And the volume of a sphere is 4/3 times pi times the radius cubed. So our first problem has to do with somebody named Keenan who wants to make a paperweight for pottery class and wants the base area to be 80 square centimeters, and he wants it to have a height of 7.5 centimeters. The density of the clay he is using is 1.7 grams per cubic centimeter. And we are asked, what is the weight of Keenan's paperweight? So what is the error in each of these problems? So what is the mistake in Keenan trying to figure out the weight of his paperweight? First off, make sure the numbers go in where they should. 80 square centimeters is the base area. That is where that's supposed to be. It's substituted in for B. H is height, and we read right here 7.5 centimeters is the height. So that's in the right spot. And then double check that works out on a calculator. So 1 divided by 3 times 80 times 7.5. Does that come out to 200? Yep, we're good there. That's the volume. So something's wrong with figuring out the density. And this should make sense. If we said density is something in a mass divided by a volume, we should see like grams per centimeter cubed here. And we are asked ultimately, what is the weight? That is the question. So we don't know the weight. Right here, the 1.7, if we go back and read closely as well, the 1.7 is the grams per cubic centimeter. That is the density. So the density should be the 1.7. And the thing we don't know, the thing we're solving for, is the weight. So we got some number divided by 200 that has to equal 1.7. There's our mass divided by our volume, and it needs to equal the density of 1.7 grams per cubic centimeter. So we're solving for W. So now it's a simple one-step equation. What's the opposite of divide? 200 times 200. So 1.7 times 200 gives us 340 grams as our weight. The second problem there, to play basketball with her friends, Evangeline needs to pump air in her ball, which weighs 0.615 kilograms when it is completely deflated and 0.624 kilograms after it is inflated. The diameter of the ball is 0.24 meters. Assuming the inflated ball is spherical, what is the air density within it? Our issue in this problem, if we read again, if you read closely, we are told the 0.24 is the diameter. Well, the formula uses the radius. We should all be super familiar at this point in class that diameter is the distance all the way across the circle through the middle. That's how most balls are, basketballs are referred to. We want just half of that. So the problem is done wrong because the 0.24 should be divided by 2 to get the radius of 0.12. So that 0.24 there should be 0.12. So now we got to recalculate the volume. If you have a TI-84, you type that in exactly how it looks. If you're using the phone calculator, which I am right now, you need to follow order of operations. 0.12 cubed is a really small number, 0.001728 times by pi gives us 0.0054 times by 4 divided by 3. It comes out to about 0.0072 cubic meters. So they did not use the radius. They used the diameter. That is the mistake. Our volume goes in the denominator according to the density formula. So this should be 0.0072. And then double check that the correct quantity is in the numerator. And if we went from 0.624 when it's inflated, we went to 0.624 when it got inflated. Ultimately, that 0.09 is correct, because when we subtract the deflated number from the inflated number, we do get the 0.009. That is our quantity, that is our mass in kilograms. And so the last part of this whole thing is take 0.009 and divide it by 0.0072, and it comes out to 1.25 kilograms per cubic meter. That is the density of the basketball. Thanks for checking this out. Please take care of the Khan Academies.